So hi, I'm Ashutosh and I'm going to demonstrate the objective of the assignment 1 in action. So I'm gonna explain the walkthrough and highlighting the key aspects and the challenges that I face and the resolution that I had done. So let's first start with the phase 1 where it was the data preparation part. So what I have done is written this data preparation script. What it will do is to take out initial 7k data points from the raw data and it will make pre-processing on that, and then going to save as a training version in the in the processed directory here. And what it'll do is the for the production data is also generate the later 3k data points and going to save those in the production data.csv, which we will use further for testing in the production after simulating it with the script that I have written. Okay, so uh, to control what is the version and everything, how it's going to save and everything, so we can what can be controlled from this configuration.yml file. So this is the central control center where we can set in all the paths, all the arguments which the code will utilize to actually uh, perform the action. So let's say if I'll change this version to version 8, so what I'll do is to use that the data preparation.py script and save the next version of the data as version 8 in the processed directory here. So let's start. So if I'll save it and run the data preparation.py, so what it's going to do is to generate the next version of the data, which is version 8. As you can see, it has successfully run and has generated this version 8. What it contains is the initial 7k pre-processed data point, where I'm dropping some columns in this data preparation in this where is it, this data preparation script, and also performing the standard scalar, and the parameter for with respect to that are getting saved here in this scalar.gz file, which we will use to further make prediction on this production data, which also these are the 3k data points are saved from this data preparation.py script. Okay, so one challenge that I faced here was about initially I was saving all 10k data points and computing the mean and the variances corresponding to all 10k data points and saving all that here in the scalar gz file. But later I realized that this while simulating the real environment, we have to use the original data, which shouldn't be standardized, because if we will use the whole data for computing the mean and variances, and then there wouldn't be the realistic setting for the deployment. So that was the first challenge that I faced, so that I figured out uh, to actually just not utilize this 3k data point sizes and then store them very uh, differently without even touching and standardizing. Just what I've done is remove the extra irrelevant columns only. So as you can see, and also this manifest.txt will log the respective uh, version. So as you can see, let's overwrite it. Okay, so as you can see, the next version hasn't been saved here. If let's say we will run this again, it is going to get saved, because what so it has been modified, so it did not recognize the change. So let's do it. Okay, so as you can see, this version 8 has been appeared here. So what I'm logging is the timestamp, which script has produced which particular data, what was the hash code for the git then, and what is the version. And if you want, then you can also write a message here in the command line, so that you can have this particular message as well here. So this was about the data generation part. So let's move on to the training. So what is this training script doing is will take the appropriate version from uh, the train CSVs that we have here, which you can control from the config file. So here in the config file, you can also select among the two models that I had used, which is random forest and logistic regression. Of these two, let's if let's say I'm using logistic regression with this particular hyperparameters, and let's say the version that we are training is v8 for the model, and let's say the version. Okay, and you can also set in here which particular script data, which particular data you would want your model to use while training. So let's say v8 we have, which we have recently generated, is what we want our model to use while training. So let's run this script and see what happens. So python 3 src train.py. So what this script going to, let me say this, so what this script going to do is to generate a eighth version of the model utilizing this eighth training data which we have just recently created. So if I'll hit run, so as you can see, the training log successfully updated at the training logs here, and as you can see clearly the timestamp that it shows is the is here, and the git hash and accuracies and all are going to be have perfectly logged here, which model, which hyperparameter, random seed, and the version. As you can see, the model has also been generated here, and this we can use to actually run in the API, which we are going to do in the phase 3. Okay, so this so the model has been successfully trained. Now let's move on to the next part, and let's change our config file again to demonstrate the inference part. So now let's say if I want my version 8 of the model to be live in the API, so what we're gonna do, okay, I can accordingly set this which port, which where I want to run that particular model, and what is the threshold which my API should use to decide whether it's a machine failure or not. So let's say if I'll set here 0.6 as a threshold, then it's going to treat, if the model predicted probability is larger than 0.6, then it's going to assign it as a machine failure. So let's start our API and see if we can successfully load the version 8 of our model or not. So python 3 src model inference.py. As you can clearly see, our model is currently live and running live on this particular 5001 port, and I have additionally written this test API script which will hit this API and going to get the results. So I'm using this manual data points to check whether the API is working correctly or not. So this is the rotational speed, right? So let's if I increase this speed, so model should predict it as a failure, and should predict the first part is not a failure. So let's run our test API to check if the model is correctly returning the predictions or not. So let's me open the new terminal and okay, so let's run the test API.py. So as you can see, the smoke test has been passed, the health is right, is the model is healthy, is returning the correct probabilities. So for the first part it's returning almost not a machine failure, while for the second part it's returning the probability as 0.56. so still we have set in the threshold as 0.6, so it's not has predicted it as a 1, but it's returning the predictions correctly. So the model is working perfectly fine. Now let's so now we have generated those 3k data points to simulate the things in production, right? So let's run our simulate drift script to actually make predictions on those 3k data points, and let's get predictions on them using this API that is running. 3 src. So what this script going to do is to save all the predictions in the production results this .css. So what I have done is actually made this file already, so what I'm going to do is to delete it so that it will be saved again here. Okay, successfully deleted. Okay, so now if I run this, it is going to get those production.csv data and going to return the predictions on this, I'm going to save it into the production folder here. Okay, so let's run it. As you can see, it's processing. So this production.csv has been created, and it has all the predictions for 3k data points, which we are using for testing. So the first one is the actual, and the later one is the predicted one. So now, as you can see, we have this generated predictions for our data. Now let's monitor. So monitor.py is the script which you can again change from this configuration.py. Here you can set in what particular threshold that you want your model to monitor. If let's say you have set here this thresholds, and model will perform poorer than this thresholds, and it is going to prompt that you have to re-trigger or not. So let's see that in action. So let's run this monitor.py scripts to actually see if what it will say. Sorry, src monitor.py. Okay, so as you can see, the performance degradation has detected. So as per the threshold that we have set there, so it has found that our recall and the F1 score is smaller than what it should have. So it prompting us to retrain the model. So let's say if we read, so we can also retrain the model here. That script I have also written to, which what it's essentially going to do is to take the production data and the latest trained data, which you can set in through the configuration file. So through this configuration file, you can see so you can set in the settings for the retraining. So what it's going to do is to save, let's say if I set this v9 and okay, this was the deployment part. So let's say if I'll save, set here v9, and let's retrain the model. So what this retraining script going to do is to take all the data. If let's say I'll say here that version 8. So now what it will do is this concatenate this latest whatever version I'll set here with the production data, and collectively train over all of them, and update this scalar file here, and retrain the model with all 10k data points. So let's see that in action. So what will happen? So I have appropriately set this configuration, edited. Okay, so now let's run the retraining script to see if it will retrain over all the data points or not. Retrain. Okay, so as you can see, the API is already live here, but parallelly we have actually have retrained our model, and the appropriate logs have been saved. The model has been saved at the appropriate location. The logs have been generated. As you can see here, the new log has been generated. Accuracies and all is appropriately described over here. And I can also now set in the final model here, which is version 8. So essentially, as you can see, I have rewritten the model version which was originally trained. So I can use this script to actually again edit this. So this was just v8, so I can use this, and I can run this inference file as well to restart my API. Okay, so it has not restarted because 5001 is already running. So let's stop it first. Control C. Now let's run it here. So as you can see, the retrained model is live, and it will return the predictions considering all the 10k data points. So this was the assignment. Now let's talk about the challenges that I had faced. The very first challenge was the major challenge was just to there was a lot of confusion as to which, because we have to parallelly maintain the version of the data, the model, and the scripts and all. So it was kind of very confusing to have all the things in the mind. And as I was training, it was like very confusing. At some point in the project, it became very confusing, and because I was forgetting again and again to changing the parameters here in the configuration file, and the result of that was the models trained, the scripts which was originally generated was were rewritten, and I had lost track the law I had lost the earlier versions of the script and the models. So I believe having an automated tool to do all this stuff would be very convenient to perform such deployment process. So that was all. So thank you.